Welcome to the course. In this lecture, we will be learning about the continuation for sequence rule analysis. So here we will be discussing about the two best criteria that is used for fitting up the sequence rule analysis, and we will be discussing with an example illustration for a web analytics setting. Module 1, Descriptive Analytics. The following are the session outcomes. This session summarizes the use of sequence rule mining technique with an example illustration and provides an overview about data segmentation and its algorithmic techniques. Let's see the definition that lies behind sequence rules. Given a database D of customer transaction, the problem of mining or extracting sequence rule is to find the maximal sequence among all the sequence which is having certain user-specific minimum support and confidence values. In association rule mining, it is completely concerned with what items appear together at the same time. Here, in sequence rule mining, it is completely concerned with what are all the items that appears at different times. Consider the following example. This example has three attributes. The first is the session ID, the next is the web page visit, and the third one is the sequence number. For the same session, there are different pages which is visited by the user. Consider for the first session ID 7, the page visit are P, Q and R followed by a sequence. Similarly, all these sessions has been visited by a specified user with a predetermined sequence. With this example, now let us explore how the rules are generated and the support value is calculated. So here I have written the sequence with respect to the sequence number of the page visit for each session. Here, session 7 is having page visit of order P, Q and R, and session 8 is having page visit of sequence Q and R, and session 9 is of having sequence P, R followed by S. Session 10 is of having sequence P, Q followed by S, and session 11 is having sequence S, R followed by P. So consider the sequence from P to R. We can calculate the value in two ways. The first step or the first approach is to calculate the support whereby the consequent can appear at any subsequent stage of the sequence. For the sequence P to R, the consequent can appear at any subsequent state of the sequence. So we have to identify how many possible cases that lies for the sequence P followed by R. So from this session, we can clearly observe that there are two sessions which is having the sequence P to R, that is session 7 P, which is having an intermediate page Q followed by R, and session 9 which is having the sequence P which is directly followed by R. So we can state the answer as 2 divided by 5, that is 5 sessions in total. So I can get the value as 40%. So the value of support here is 40%. And the second is, we have to consider in this step or in this approach, we have to consider only the session in which the consequent appears right after the antecedent. So for this case, we can consider the session 9 alone, because this session is only having the page P which is directly followed by R. So as an answer, I can write 1 divided by 5, which is of 20%. So this is the value for step 2. So we must remember that confidence of a rule from A1 to A2 is defined as the probability of A1 given A2, which is equal to the support value of A1 union A2 divided by support of A1. So the probability of A2 given A1 must be considered as a phenomenon while evaluating the sequence for any set of items, that is maybe of type P to Q or Q to R or P to R and so on. So this is the way, this is the possibility in which we can calculate the value of support for sequence rule mining, which is clearly focused on what items appear at different times for a given set of transaction. Reflection spot. Here the answer is, in association rule mining, it is used to detect frequently occurring patterns between the items, and sequence rule mining, which detect the sequence of events. So these are the application which is majorly concerned with sequence rule mining. They are web log analysis, tracking the path traversed by the user in a web analytics setting, DNA sequence analysis, that is in the field of bioinformatics, alarm sequence analysis, and finally customer behavior analysis. So here, sequence rule mining is completely concerned with the maximum of real world application. And the next is data segmentation. The aim behind data segmentation is to split a set of customer observation into different segments in which the homogeneity within a segment is maximized, that is cohesive, and the heterogeneity between the segment is maximized. So it is of type hierarchical and non-hierarchical. This type of descriptive analytics has its application in the major field of understanding the customer population, and it deals with the efficient allocation of market resources. So this is the flow depicting the type of data segmentation into hierarchical and non-hierarchical. And hierarchical is of type agglomerative, divisive, and for the case of non-hierarchical we can say self-organizing maps and k-means algorithms. So let's see what is agglomerative and what is divisive clustering. Divisive clustering starts from the analysis of whole data into a single cluster, and it breaks this single cluster at each stage into smaller cluster until one observation per cluster remains. So finally, we will be getting the output as the single individual clusters. So agglomerative works on the another way, starting from all this set of single individual cluster observation, and it tries to continue to merge the cluster at each stage which are most similar until all the observation forms a big cluster. That is a single big cluster at last. So the process of dividing this cluster or merging the cluster lies at a splitting criterion. That is, a similarity rule is used here. So the most popular similarity rule that is deployed to merge or break the cluster is Euclidean distance and Manhattan distance. And one thing you must consider that the value calculated by Euclidean distance will always smaller than the Manhattan distance. The second category, which contains self-organizing maps and k-means clustering. So the process of self-organizing map allows to visualize and cluster high dimensional data in a low dimensional grid of neurons. In general, A self-organizing map is a feed-forward network with two layers. Here, the neurons from the output layer are usually ordered in a two-dimensional rectangular grid or a hexagonal grid. So in this algorithmic technique, each input is connected to all the neurons on the output layer with weight value. With a keen focus on the number of variables that is used for analysis. And for the next category, that is K-means clustering, a non-hierarchical procedure which starts with the selection of observation as an initial cluster centroid, and it then assigns each observation to the cluster that has the closest centroid value. And finally, when all the observation has been assigned, to recalculate the position of the K-centroid. So this is the working procedure behind this non-hierarchical technique, that is self-organizing maps and K-means clustering. So these are some of the applications behind the data segmentation methods, that is filtering of spam messages, analysis of network traffic, document analysis, sales marketing and fake news detection. This is the reference. Upon summarizing, here we have learnt about how a sequence rule is formed for the given web analytics setting and how we can carry out data segmentation with respect to agglomerative and divisive clustering technique for the given data. Thank you.